Welcome to the Soil CRC's Building Technical Capacity for Improved Soil Management webinar series, Soil Characterisation and Data. In this video, the Department of Primary Industries and Regions South Australia Principal Consultant Brian Hughes discusses soil pit protocols, descriptions and characterisation, and the importance of geographic context, including how to access online soil data for South Australia.
Some of you will know some of this stuff. When I started thinking about what we do when we look for soil pits, it's probably I actually have learned something over the years, so that was good. Actually came up with a few things, that was good. Let's talk about location. I suppose this example of photo there, you can actually see actually digging with a massive excavator, but we've actually kept the topsoil and the subsoil separate, as you can see there, so they can put them back in the right order. But when you sort of think about the location, you really want to make sure you're on the soil type that you're selecting. Just got to turn these phones off. And how long it's going to be open for. So basically, sometimes with pits we've left them open permanently. So in that case, you want to stick it in the corner of the paddock if you can, so it can be fenced off. Whether you need to use it for field days, you need to be able to actually get to it if it's a field day, and also even things like excavators normally come on pretty big trucks, so you don't want it too far into the farm, because they'll want to take it off probably on a fairly stable spot. And I suppose just some of the safety issues and things like underground water and power. If there's a water line there, you'll find it when you dig the pit, which I've found a couple of times. So pit dimensions, certainly for field days, I normally prefer sort of a T-shaped type of one where you basically have the face on the top of the T and you have a ramp going down to that. If it's just a basic soil survey, you really just dig a hole with a bit of a wedge on it, just so you can sort of get into it really. And I suppose one thing I always find important often with the operators is really just having a good discussion with them beforehand, just to make sure they don't disturb the face wall when they're digging it. And particularly if they're new to digging soil pits, you really need to, if you're digging a T, you'll actually dig across the top part of the T first, I suppose, and you'll certainly smear stuff on the face that you want to use, but you won't actually disturb it too much. Normally we max out at about 1.5, 1.6 meters deep, and I suppose on really unstable soils that's probably even too deep. So if you're on a soil over water table or something like that, you may want to go shallower than that as well. And there's nothing worse than going to when farmers have dug your pit and it's 2.5 meters deep, and you don't want soil that deep over your head in case it caves in. The pit face, I've talked a bit about this pit face, just making sure the operator doesn't damage it. And the other thing is to aim to have the pit face so that you've got the sun in the right place when you take your photographs, if you want to photograph it. So a lot of ours, we certainly do, north, or if it's a morning pit, we'll do it sort of more northeast. If it's sort of afternoon, it might be more northwest, is where we've got that I suppose face, so that we can get sun over that face when we've got it ready. Cleaning the pit face, I always find it easy to do some when you dig it. Often some soils get really hard after they've been sitting there for a while, and you need sort of a flat-edged spade or a shovel, small mattock or geology pick and knife, and really, clean it off initially and take your photographs, but also you can you'll have to clean it again if you've got a field day in a week or two's time, and removing sort of a couple of inches off the face of it as you do, you can get rid of all that smeared stuff. Also learned over time to take a block of wood with me for field days and things that you may need to put in the base if it's wet, and certainly if it's a couple of weeks after, when you're having a field day, you might have to pump some water out of it as well. And the pit on the right there at Lock, actually at the field day on that one, it doesn't look very wet, but there's clay down the bottom. I actually lost rubber boots in the bottom of that somewhere when we did it. Now, soil pit assessment, and I suppose the photo on the right there now, what's wrong with this one? This is one of my very early ones. When I look back, I'm a bit embarrassed about where I can't remember why we left pock marks all over it. So, have a think about, you really want to try and avoid those shadows, I suppose, on your pit faces when you're photographing it. So that would have been much better done with I suppose a shovel and much straighter edges on it in that case. So when you're assessing them, clean them off first, avoid the shadows if you can, and clean from the top. make a straight face on sand, or other soils you have to sort of pick away a bit and try and get some of the structure showing without having too much shadowing. Always describe and photograph before you sample, as you sort of destroy the face when you're sampling. Identify the layers first, describe them, photograph and sample in that order. And ideally you need a pit soil tape. You can actually purchase the ones like the ones I've got there, and various people have made their own in other ways as well, and can probably find out where we got those from. We did buy some fairly recently, but I can't quite remember off the top of my head. So Cameron, soil description sheet, I'll show you some examples which are a bit more elaborate than probably what you need, but have some sort of sheet which sort of helps you, remind you to do all the things that you want to measure on it, I suppose. There's a range of textbooks which we can show, and particularly the Soil and Land Survey handbook is sort of the Bible and all this sort of stuff. And you'll need some sort of soil kit, and which will include your water bottle, your pH kit and tray, some acid if you're in South Australia looking at calcareous soils, a colour book, something for just doing dispersions. Then if you want to do it, you may need to sift the soil if it's got a lot of rock in it. We use magnets for some things, and a soil tape and nails and things. So I suppose moving on to the actual act of doing the soil, so soil description, and there's lots of stuff around on this, so I'm just touching on it a bit. Normally, certainly with a soil pit, we'd want some sort of landform information, the element, some GPS location, so you can use it forever, I suppose. And I sort of say that because back in the 80s and 90s, the pits that we did on places like Eyre Peninsula are still being used, and to realise at the time that how long that information lasts for and gets used. Assessment of surface structure, vegetation, land use, geology, if you know it, and some routing depth information. Normally, this sort of across the pit itself, and then for each layer, basically recording the depths. Linking those layers to horizons, if you know about horizons, and if not, they're in the yellow book, I suppose. We'll tell you about those. Where layers are particularly too thick, you may want to subsample those into smaller layers. So if they're getting 30, 50 centimetre increments, if you've got a layer that's very consistent for a metre, split it up, I suppose is what I'm saying. And then for each layer, there's a range of basic tests that you do in the field. So texture, colour, pH, acid reactions in South Australia, coarse fragment segregations, carbonate layers. And in some soils, you may want to do a field dispersion or water balance test, and certainly assess the root growth as you're going down on those. So this is an example of a sort of elaborate soil description sheet. I'm not expecting you wouldn't need all those, but something a bit similar like that. If you make something up which has those core things that you want to look at, and that just gives you a bit more rigor to what you're doing. If you're doing a whole range of pits, I suppose you'll sort of end up testing them for the same sorts of things. Now, just sort of moving on. So I'll just briefly skip through some of this stuff, which will be really quick because there's a lot of stuff in this. So certainly looking at, as I said, the first thing at a soil pit is really looking at the layers. And this is one from the mid-north, where you've got an A horizon, organic darkened sort of surface. You've got a washed out sort of layer, which can be called A2 or E horizons, depending where you're from. We're moving into the B horizons, where the clay has accumulated. Further down, we're looking at where carbonates accumulated, and down the bottom of the pit, we're seeing some of the substrate material there. And understanding of that is pretty important for a lot of our South Australian soils, and even more so in sort of horticulture. And the layer thing, I said, firstly do that. Texture, I'll just flick. I mean, you all know how to do textures, and the interpretation of texture really relates to a lot of the soil characteristics. So the clay content is dictating a lot of the moisture characteristics and other things. I won't go into that too much. Structure, there is a lot of information on structure around, but you're really trying to have a look at understanding whether it's got a good crumbly sort of structure. Is it hard setting? Sandy soil often really doesn't have much structure, but it just sits there. Have we got things like columns, and which may be linked to sodic soils, and I suppose again, looking at the structure in terms of where the roots are as well is useful in terms of sort of understanding whether you've got sort of subsoil limitations in your soil as well. Dispersion, again, you would have all seen these. You can do these in the field and just have a bit of a quick look and just see whether it slakes and whether it disperses. Again, when you're looking at I suppose subsoils in particular, and whether they're limiting root growth, just by placing your soil into, so you need some distilled water or rainwater with you to do these. Colour, there's multiple colour charts around, but the colour will tell you a fair bit about some of the characteristics of the soils in terms of drainage in particular. So bright red will indicate good aeration and drainage, while some of the paler browns and yellows or mottled horizons, so certainly record models, if you're describing your soils, will indicate poor drainage, and then very pale colours can indicate sort of low fertility, while sort of dark, high organic soils will indicate the opposite. And for South Australia and I suppose parts of Victoria, the understanding of the carbonate in the soil is quite important. This is not actually in the yellow book, but it's really the method that's used throughout the sort of irrigation districts in the Mallee and Eyre Peninsula, is to really classify the carbonate layer into. So class 1, we have I suppose a classification system which is really fine carbonate in clay, and it's often associated with sort of poor drainage and root growth, and also some of the subsoil toxicity, things like boron and salt that we see. Class 2 is sort of sheet or boulder or laminar calcrete, and I suppose the class 3s are split into different categories depending how many fragments there are. Often we find class 3B and 3C, the roots actually grow through those quite well, even though they look quite rocky. And that's the deeper class 1 or the 3A is where we start seeing some of the restrictions to root growth. And class 4 occurs in very sandy matrices. But so understanding that actually gives us a sort of a model, I suppose, for some of the certainly irrigation soil surveys and where the roots are likely to grow and where some of the toxicities occur. Water repellents, again, there are tests around for water repellents, and you can have a bit of ethanol in your kit if you want, or just you can use the water test as well, just to see how long it is for water to move into the soil. So some of the properties can't be observed through the field, so you then go down your path of sampling the layers and getting some chemical analysis done. For generally, we would sort of do a range of things from pH, salt, toxicity, things like chloride and boron, exchangeable cations. We may get carbonate percentage done, depending on the soil, and then a range of the fertility measurements, so things like phosphorus, potassium, sulfur, and the trace elements, and certainly organic carbon. And I suppose in some cases we've looked at some of the the biological tests on the surface to give us an idea of some of that sort of stuff as well, and in some cases more detail on the physical tests. So we have done bulk densities or whatever from the pit to look at some of the physical characteristics as well. But certainly most of the historic ones have had this sort of range of, I suppose, the chemical tests from either fertility or toxicity. Again, for the the carbon protocols, if you're going to try and measure, you need a bulk density. It goes with your carbon figure, so to calculate those sorts of things. And that's then presented, I suppose, in some of the results. So I suppose good soil description, give you some information, hopefully, on the range of those characteristics. So I talked about some of the physical barriers to the root growth in that soil type, whether it's susceptible to waterlogging, salinity hazard, whether it's got a water table, you'll find out, what's the deep drainage characteristics, any chemical barriers to root growth, soil pH, and I suppose the implications of that, and general fertility status, and also just that root zone depth. And my experience, I think I've probably only seen really 2 soil pits over the hundreds I've looked at, probably where I've seen really good root growth all the way down, interesting enough, which probably tells us something about our soils. And you can calculate things like total and readily available water holding capacity from that characteristics. Now, I think I'm going all right for time still, aren't I, Felicity? We've got a bit more. So that's really 101 soil pits and description in 15 minutes, which is probably a bit much. So some of the sort of support things around, I suppose, I was just going to talk about that, the Australian Soil and Land Survey handbook. See that one, the yellow book, is that one. So that's really, if you're getting into a lot of soil description work, that's really a standard definitions across Australia that are used for texture and all those characteristics. And it's really like a little Bible, I suppose. So if you're wanting to be consistent in how you do things, it's really good to get one of those. And you can, and it's got the I suppose the site elements through to the soil description characteristics as well. And that's constantly being revised and updated. I think they would hope to eventually have it as an electronic book where you can sort of hook in and see photos of different things on the web. Monthly colour chart you need is one of those. If you're going to do colours consistently, and you can match the colours to that. And I suppose the so I probably should get off of that anyway. So monthly colour chart, we've actually found some of the cheaper ones aren't particularly good. So you need to make sure you're getting one that's a true monthly colour chart, not a cheap version, because the colour is a bit different to some of the others. And I suppose the other books, which there is an Australian soil classification if you want to get into a classification system for your soil. And that I suppose is the uniform Australian one, and I think is much easier. You can actually classify your soil quite quickly using that one. There's other soil classification systems through there, but if you're looking to sort of, I suppose, use the soil pit and use it in some sort of scientific publication, you should be classifying that soil according to the soil classification system. And I suppose in South Australia, some of the other things, we'll talk about the database in a minute. There's quite a good Soils of Southern Australia booklet, I suppose, which has really got a lot of good, Hall and Mashford and Co, a lot of really good information on 50 different soil groups. And we have a range of other little versions of these that we've done for field days and that, which people want them, which we sort of modify some of that stuff to make it much more simpler for farmers, but talk about texture and the implications and other things in those, and build in sort of local information and soil pit information. I suppose just moving on to the last part, there is some stuff around. A lot of soils information is now on the web, particularly through Department of Environment and Water in South Australia. Some of the main bits of that are the nature maps, data SA, environment data SA, and I suppose soil sites SA. And I'll just quickly whip through those. And so if you look at, I suppose, the area that's really been mapped properly is marked in red in South Australia. So that's sort of what we'd call our agricultural areas. So there's sort of much more limited information on the pastoral zone and the Aboriginal lands and things. And this one's actually off of the Enviro data. So this is really looking at some soil attribute mapping, and this is a coverage of wind erosion potential, but there's something like 24 or so of these different layers. So it's really assessing from low to high wind erosion risk. On that same, you can actually hook into all the soil characterizations sites, and you can actually see all the sites are marked. And there's a lot of them when you start. So all these you can hook into the sort of a 2-page summary of that soil, which will basically include the description on the front page, some site information, and then on the second page will be some of the chemical data and I suppose the interpretation of that. So I can't remember how many of these, but there's a lot of these around the state. Now a lot of them are actually getting, they're back to 1980. Some of them, some are more recent. We're still putting stuff on there as we go. Looking at nature maps again. So this is again an interpretation for acid soil risk in this case, and so there are some which link into some more land use potential as well. And another data set, I suppose, on there through Data SA, you can actually now get in, so you can get into these range of acidity and other things. I said there's 20 odd of these types of things on there. And moving through the soils of Southern Australia, so the James Hall document is actually on the web there as well if people want to access electronically. So Soils in Southern Australia. And then I suppose the stuff that I've just actually put on there recently is all the individual soil descriptions that were taken as part of the program to establish the maps. So you can actually go into the original actual things that the field description sheets that people did around the state. And there's, I don't know, something, there'd be tens of thousands of these. So when you look into that soil data or soil site SA site, you can see the ones in orange, sorry, ones in green are actually the soil characterisation sites, and then the other little blue ones are actually just the field description sheets of when they're actually doing the mapping. So that data is actually now all on the web. These are some Dave Mash's ones, again, looking at, I suppose, the field description sheets and the characterisation sites, which are CH159, those types of things. And so you can basically get all this information on the web now. And the sort of information you'll get is that in some you'll just get a description, others you'll get description plus, I suppose, chemical tests that were done.
Thank you for watching. If you found this information useful, there are many more related projects to discover at our website. Please like this video and subscribe to our YouTube channel for more Soil CRC webinars, project updates and conference presentations. This webinar series was produced by the Soil CRC, jointly funded through the Australian Government's National Landcare program, to build the technical capacity of natural resource management agencies, Landcare and grower groups to deliver soil health information to farmers for improved soil management. For more information about our projects, visit soilcrc.com.au.